Welcome back, Mastery Algebra 1 peoples. I'm Mr. White. This is lesson 4-4. What we're going to do is we're going to look at graphing a function rule. So our objective, we need to figure out how to graph equations that represent certain functions. This is in the heat of the night. Randy and a group of his friends went camping for a weekend in the desolation wilderness. At night, the crickets were making so much noise that no one could sleep. Randy remembered from his science class that a good way to approximate the temperature was to count how many times a cricket chirps in 1 minute. And then he would multiply this count by 1/4 and then add 40 degrees. So the group decided to use Randy's idea to estimate the temperature. So they counted 100 chirps in 1 minute. So then Randy computed the approximate temperature to be 1/4 times 100 plus 40 equals 65 degrees. What we need to do is we need to write this formula used to approximate the temperature. If we let T equal the approximate temperature in degrees Fahrenheit, then the N will be used in the function as the number of cricket chirps that we get in 1 minute. So if we put this formula together, we're going to get T for the degrees that we're trying to get from, what are we doing? We're multiplying 1/4 times whatever number of cricket chirps we get in a minute, and then add that 40 degrees. We now have a function. So what we need to do is figure out, well, how do we choose appropriate values for n? Well, if we look at the graph that's already down below, we notice that it's kind of already set up for us, where it starts at 0 chirps per minute on the x-axis down here, and then as we go right, it goes to 40, 80, 120. So the numbers are going up by 40, but each little box increment is actually going up by 20. And then if you notice on the y-axis, we are going up by 20 also. So 20, 40, 60, 80, 100 degrees, and so forth. Okay? So if we take our x values, our input, we're used to seeing tables x and y go vertical. Okay? But now what happens if we have a horizontal table? Okay, what we're going to do is, in the vertical table, x input is on the left, y is on the right. Well, in a horizontal, we put x on top and y on bottom. So in this case, our input is the chirps per minute, which is n, and our temperature degrees T is the y. So if we pick the numbers that we have suggesting from the table or from the chart, we'll start at 0, going to go to 40, then try 80, 120, 160, 200, 240, 280, and finish up at 360. So what I did is I took the numbers that were on the x-axis and plugged them into the top boxes, or our input for chirps per minute. Now what we have to do is we have to take our input and plug them into the formula that we made just above, and then calculate the actual temperature in degrees we got. So for instance, if we take the first one, we took 0. If we plug in 0 for n, okay, so when n equals 0, we get 1/4 times 0 plus 40 ends up being 40 degrees. If we take the next one and go 40, so if n equals 40, now we're going to go 1/4 times 40 plus 40. 1/4 of 40 is 10 degrees. Sorry, 10. And then 10 plus 40 is now 50 degrees. And if we go to the next one and do 80, we'll take 1/4 of 80 plus 40, which is now 20 plus 40. So now we're at 60 degrees. And if we do one more, usually shown work for about 4 or 5, take 1/4 of 120, which is 30, and then add 40, which gives us 70 degrees. Okay. So take a minute, fill out the rest of the chart, check back with me in a few minutes. Alright, welcome back. So we should have had 40, 50, 60, 70, 80, 90, 100, 110, 120, and 130. Now if we graph these points on the grid, okay, we'll start at 0 and 40. So for 0 chirps per minute, we're going to go up to 40, we're going to put a dot. And then we're going to go down the line, so at 40, we're going to go up to 50. Remember, these are increments of 20, So 50 will probably be right in here because it's 60. So if we go right to about the middle, then we go to 80 is 60. 120 is 70. So it'll be about right here. 160 is 80. Or if I just go over every couple, 240 gives us an easy 100. 320 gives us an easy 120. And if we go to 400, which we didn't have on the graph, it should be about 140 right there. Okay. If we connect the dot with a handy dandy line, starting at 40, we're going to go all the way outside of the graph, because the chirps per minute could go on, and we get this graph of the function here. So answering the questions that we have. So if we answer question 4, what is the starting point on our graph? Starting point seems to be as we go start left and go right, it is this value right here at 0 chirps per minute. So if we have no chirps per minute, the temperature is actually suggests and estimates to be 40 degrees Fahrenheit. What is the rate of change of slope? Okay. What we mean by that is, as the chirps per minute go on, how is the degrees or temperature degrees changing in Fahrenheit? Okay. So notice on the graph, there's two ways you can do it. Each box we're going by 20. So as we go by 20, okay, or we can look at this as it goes from 0 to 40, 40 to 80, 80 to 120. We notice if we can go back up to our chart up here, it goes from 40 to 50, which is an increment of positive 10. 50 to 60, positive 10. 60 to 70, positive 10, and again, positive 10. So that goes on down there. And we know that on the top, it was increasing by 40, 40 to 80, and 40 to 160. So 0 to 40 is 40, 40 to 80 is 40, 80 to 120 is 40. So as our x is changing every 40, our y is changing by 10. So I can write up here, for every 40 chirps per minute that we increase in the x, our temperature degrees is increasing by 10 degrees Fahrenheit. Okay? We can actually reduce and make this 1/4, which simply means for every 4 chirps per minute, there is an increase in 1 degrees Fahrenheit. Number 5, if we use our graph to find the temperature if you count 300 chirps per minute. So if we count 300 chirps per minute, so I'm going to go all the way to where I see 300 chirps per minute, which is right here. I'm going to draw a line that goes up the graph. And then once it hits the graph, I'm going to take that graph and I'm going to draw it all the way over across till it hits the y-axis. So it should be about, and we can move this a little bit. So it's about here. Maybe move that. So if we look at that, we say for 300 chirps per minute, if we go up and over, it seems to be about, remember this is about 100 degrees. So we're close to 120, so we can call it maybe a little bit more than 115. So you can call it about, we'll call it about 117 degrees Fahrenheit. Okay. If we go the other way, and for number 6, use your graph to estimate the number of chirps per minute you should count if the temperature were 62 degrees. So now we're going to take our line, and if we go to about 62 degrees, so here's 60, and then halfway up would be about 70, so we're going to go a little lower. If we go over to where we think we're going to meet, and then once we get there, we'll draw it down, so it should be around there. So we know this is 100. So it's not quite 100. So if we read our graph, we go over from about 62, hit the line, go straight down. For chirps per minute, we seem to be about maybe 92 chirps per minute. So we'll call it approximately 90 chirps. Could be 92. So if we take our graph, look at about 62, go over till we reach the graph, go down. We should be about, I'm guessing if this is about 90, let's go a little bit more, so we can say it's about 92 chirps per minute. Now on 7, we need to check our accuracy of our answer by substituting in our answer 92 into the formula that we originally had. So we know the formula, if you remember, just by looking up, we know it's 1/4 n plus 40 degrees. So we're going to plug in 92. T equals 1/4 of 92 plus 40 gives us a degrees Fahrenheit. When we take 92 divided by 4, add 40, we get 63 degrees. So we are close. All right, next page. All lined up. Sandy recently signed up for a long-distance telephone service from Phones R Us. The Phones R Us charged $4 per month for a flat rate plus 10 cents per minute long-distance phone call. So the algebraic formula that we came up with is the cost of the phone call is equal to, we're going to take the amount times the number of minutes that we use, the M, and then add that $4 per month charge. So if we look at our table, we need to complete the following for the value of the cost. If we have our X value, our monthly minutes, which is we're going to call M, and we look at 0 minutes, 2 minutes, 8 minutes, 14 minutes, and 20 minutes, we need to get the Y, or that dependent variable, and figure out the monthly charge. Take over here number 2, and then we graph the points that we get. We're going to take 0, plug it in for M, okay, add 4, and we end up getting $4. If we take the next value, and we plug in 2, so we made 2 minutes phone calls, we get about $4.20, so $4.20. If we plug in 8 times 0.1 plus 4 gives us then 480. So we plug in 480 and 14 times 0.10 plus 4 gives us $5.40 for 14. So then if we multiply by 20, add 4, you should get 6. All right, go ahead and hit pause. Graph the lines, answer questions 4, 5, 6, and 7. I'll see you back here in a few minutes. Go. All right, welcome back. Let's see how you did. So notice, graphing the points on as the monthly minutes increases. Notice your monthly charge in dollars will increase as well, hence the linear function. Okay, when we connect these points that you graphed above, okay, you have just graphed a linear formula. Okay, that's what we call it. It is called linear because it forms that straight line, and in the formula, N represents the number of monthly minutes and C represents the monthly charge. So when we input the monthly minutes, we get an output of a monthly charge in dollars. Okay. What's the slope or rate of change? Notice what's happening. If we look at rate of change as our X changes, then our Y changes. So look at it as Y over X. So our rate of change, if we actually look back at our formula up here, okay, our rate of change is saying, well, as the monthly minutes changes, what's happening to our charge? If we notice this 10 cents right in front of it, we are being charged 10 cents per extra minute. So as each minute increases, our amount is going up 10 cents. That is our rate of change. So we could write it as 1/10, or we could say 0.1, or you could say 0.10. What's the starting point? Meaning, if you make 0 calls, okay, what is the cost? Well, 0 calls, the point we got was 4, which means for 0 calls, we are still charged $4. That's that monthly fee. What does the fourth point on the graph mean? Okay, the fourth point we got was 14, 540. What does that mean? That means that, what are we doing? We're making 14-minute phone call. We were charged $5.40. So at 14 minutes, the cost will be $5.40. And 7, what you should have did is, if we use the formula to find out if it's 25 minutes, we're going to input this in for M. So we have our cost, 0.10. We're going to input 25, add $4. We get $2.50 plus 4, which gives us our cost is equal to $6.50. We're going to look at identifying continuous and discrete graphs. Two types of things that we can have in data: continuous with discrete. Continuous data, this is data that we have infinite many values associated with measurements without gaps. So for instance, volume, weight, height, they have decimal equivalents, or I can drink about 251.3 liters, 251 milliliters of water, vice versa, where a discrete graph is your finite number values, your countables. I have $0, $1, $2. There are 10 people in the classroom. There are 28 desks in the classroom. You cannot have 28.5 desks. Okay, so that's a little bit of continuous and discrete. So we have a farmer's market. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make cheese and the price at which he sells the cheese are shown. Okay? So write a function for each situation. Graph each function, and then is it continuous or discrete? So we know in the gallons of milk, we know that 1 gallon of milk makes 16 ounces of cheddar cheese. And then each wheel of cheddar cheese costs $9. So the one thing to look at this is you can have so many certain gallons of milk versus each wheel. It doesn't talk about a wheel and a half or a wheel and a quarter. It just mentions that each wheel. So notice with the gallon, that weight of cheese in ounces depends on the number of gallons of milk we use. So what we could say is W is equal to 16 times that measurement, okay, or milk, the gallons of milk. Where each cheese wheel, once we know how many cheese wheels that we need, we can multiply by 9. So the amount of money made by selling each cheese wheel is A equals 9 times N. N being the number of cheese wheels sold. So what we need to do is we need to take these functions and graph them. So for the first one, if we say instead of X, we're going to call it gallons of milk. And then we have our ounces Y of cheese. Or another way of looking at it is the gallons of milk was your M. This is our weight, or W. What are we going to do? We're going to take 16 times the values that we have for a gallon of milk. So we could say Y is equal to 16X, or weight is equal to 16M, which is the same thing that was up there. So if we start off with simple one, let's go 0. If we take 0 and we input it in for X, we're going to get 16 times 0, which is 0 ounces of cheese. If we do 1 gallon of milk, so now we have 1 gallon of milk. We input 16 times 1, we're going to get 16. And if you notice, if we do, say, 2 and 3 gallons, we're going to go 16 times 2 and 16 times 3, so we get 32 and 48 gallons of milk. If we go over to, and we have four quadrants here. If I just take one of the quadrants, we'll just use this upper one. So draw my line. Here's our y-axis. Here's our x-axis. Notice I just went by ones on the gallons of milk. So if we started here at 0, and then I just go 1, 2, 3, 4, 5, and these are number of gallons of milk. We're on the x-axis. It starts at 0, but it looks like it goes up 16, 32, so every 16. So we'll just go 16, 32, 48, 64. And this is number of ounces of cheese. If we graph these points, so 0, 0, 116, 232, and 348. If you notice, so if I asked you 4 times 16 would keep going, we will get 64. If we were to do 5 times 16, we would go up to 80. With the gallons of milk, could I actually plug in, say, a gallon and a half? The answer is yes. So if I connect these lines, this is the linear function that we could get. We call this the continuous graph. If we look at the second part, which is the number of wheels, okay, we're going to take, remember the wheels, we're going to say that each wheel costs $9. So if we say y, the cost, is equal to 9 times the amount of wheels, which I think we used n, then we can figure out and say, well, if I start off with 0, 9 times 0 is 0. If we sell 1 wheel, then we get $9. If we sell 2 wheels, we're going to get 9 times 2, or 18. And the last one, if we just increase by 1 more wheel, we get 9 times 3, which is 27. So if we draw this graph, our x-axis here is the number of wheels. Our y-axis, this is the amount of money. We started at 0, went 1, 2, 3, 4, and then our cost. Notice what our cost did. It started at $0, went up by 9 each time. So if we went up by, say, 6, 12, 18, 24, go to about 30. And then if we put a dot that represents the amount of wheels, so we'll go 0, 0, didn't make any money. But if we sold 1, we went to 9, so increments of 3. And if we sold 2, it was 18. And if we sold 3, we were at 27. And if you wanted to keep going, 4 would have been 36. Now, one thing about this is, can we sell, they're sold $9 per wheel, so we really can't sell a wheel and a half or a wheel and a quarter, so we're not going to draw a line, and we have distinct points. Okay, this is our discrete graph. All right, example 4. What is the graph of each function? What we're going to do is we have the function y equals absolute value of x minus 4. We have our grid here that starts at 0, 0. Okay, let's plug in, at least always plug in 7 points. Same thing for the second one. When we have y equals negative x squared, okay, we want to try 7 points, plot them. I'll start you off with the first one, and then you can continue. So let's say we started at, say, negative 2. And then we went increased by 1, so negative 1, 0, 1, 2, 3, and then maybe choose, I don't know, 1 more. Let's choose 11. So if we input negative 2 into the x, we're going to get the absolute value of negative 2 minus 4, which gives us negative 2. Do 1 more. Absolute value of negative 1 minus 4 equals negative 3. So go ahead, hit pause, finish the absolute value, and then the second one on the bottom. Check back with me in a few minutes. Go. Welcome back. If you notice, we get this V function. Absolute value equations are V-shape. Main thing, check and see, did you draw the lines all the way out through the whole graph? Okay, and we should have gotten negative 2 for the y, negative 3, negative 4, negative 3, negative 2, negative 1, and 7 just touching up a little bit further. Okay. On the bottom one, okay, when we have an x squared, we call that a parabola. So the big key is make sure you square first, then multiply by negative. So our answers were negative 4, negative 1, 0, negative 1, negative 4, negative 9, and negative 9. So we get this parabola shape. Don't forget to continue on. So you're going to look at Paul and draining his swimming pool. Check with us and see if you have any questions. Make sure to finish this. And remember to do your best, forget the rest. Bye for now.